Hello, friends. You are on the Galactic Express channel. Since 2004, a NASA probe dubbed Cassini-Huygens has orbited Saturn, making multiple flybys of Saturn's largest moon. Titan is an enormous planetary body, the second largest moon in the solar system, 50% larger than the Earth's moon. If it wasn't in orbit around Saturn, Titan would be a planet in its own right. But most impressive of all, Titan, many scientists believe, could now, or at some point in the future, be an abode for life. But at 840 million miles from the Sun, 9 times farther than Earth, Titan is beyond freezing. The mean temperature on its surface is almost 300 degrees below zero Fahrenheit. It is so cold, and water on the surface of Titan is frozen to such an extreme state, it behaves like rock. The rocks in this blurry photo taken by the Huygens lander are, in fact, water. It is so cold that hydrocarbons that are gases on Earth, such as methane and ethane, are in a liquid state on the surface of Titan. The Cassini flybys have spotted them.
We're seeing a lot of what looks like organic materials on the surface, and we're seeing large bodies of liquid, but it's not liquid water, it's liquid methane with possibly some ethane dissolved in it. There are huge lakes on the size of Great Lakes or small seas.
Astrobiologists are beginning to entertain the notion that organisms could have developed in those lakes.
Life could be very, very exotic. We have been thinking of life in terms of water and liquid water, but could there be life in liquid hydrocarbons? Perhaps. Life on Earth exists in some very difficult places that you wouldn't expect to find life, and we call these organisms extremophiles. That's because they can live under extreme conditions. For example, here on Mona Lake, very alkaline lake, and yet extremophiles have been found living here.
Another possibility is that life formed much earlier in Titan's history, when a great deal of heat from the initial formation of the moon remained. At that time, conditions on Titan would have been very similar to those on primordial Earth.
There's a lot of water there, there's a lot of nitrogen, a lot of other things. So you've got warm water, nitrogen, carbon. And we think some of these chemical processes that went on Earth to start generating the biological, pre-biological materials that later on would be incorporated into life, that may have started on Titan also, with the same kind of chemicals present in a warm environment.
Some think it's possible that if Titan's core is still warm, microbial life at least might still be present deep below the moon's surface. Living organisms have been found thriving in damp rock crevices 2 and 3 miles below the surface of the Earth.
Now, if you go deep down into Titan, and when I say deep down, I'm talking about 50 kilometers or 100 kilometers, maybe even a couple of 100 kilometers, just like Earth, as you go downward, it gets warmer. And it looks like probably at Titan, there are materials mixed in with the water, such as ammonia, that can act as antifreeze. And we know this liquid water is a wonderful medium for all kinds of chemical reactions, including the reactions that generate amino acids and other prebiotic chemicals.
At present, though, close observation of Titan's surface is limited. The moon is cloaked in a dense atmosphere of nitrogen and methane. The Cassini probe is equipped with an infrared imager, but photos shot in a visible wavelength are often much more useful to analysts.
You have to somehow get around this opaque atmosphere that's obscuring your view of the surface. but to really see what's going on the surface, and notably to get a really firm idea of what is the composition of all these different things that we see on the surface, it turns out we're going to have to go down there close to do that.
The Huygens lander has touched down on the moon and sent back images, but the lander is not mobile.
When you land on a planet, of course that brings tremendous advance in terms of science, but it's only one spot. So how much of the Earth would you know if you landed on the Sahara Desert, for example? You wouldn't see the kind of life that we see here.
One possibility for exploring vast expanses of the Titan's surface would be to use a craft that works much like a hot air balloon on Earth. NASA's Jet Propulsion Laboratory is developing a balloon craft that would carry both imaging gear and equipment for studying the Titan atmosphere. Engineers consider a balloon the most stable platform for such a mission.
If a balloon loses its electronic control for several hours, no big deal. You can have something on board that senses that and tells the balloon, okay, close your ascent-descent valve and just go to a safe altitude and sit there until you get further instructions.
But while complex missions to far-off moons within our solar system are exhilarating and often return great scientific insight, the promise of discovering more than primordial extraterrestrial life is slim at best. The hope of finding intelligent, technology-producing life seems greatest when we look beyond our solar system to neighboring stars. While we may never encounter such life, for most scientists who study the universe, the notion that it exists somewhere makes perfect sense.